Is that it? The movies are over, so nobody's coming to class? Look at all you loyal people. I really appreciate it. Oh, I guarantee you, most people, when you think of toxic items in your home, the first thing is you're going to say to yourself, especially at my age, I would say, oh, good, something to think about at 2:30 in the morning when I wake up. How many of you wake up at 2:30 in the morning and think about things? Do you know that the fact of the matter is that those things that you worry about between 2:30 and 4:30 in the morning, the vast majority of them will never happen? For the announcements this morning, I didn't turn off my cell phone. I'm going to go over there and turn off my cell phone while I'm giving the announcements. Wisdom Wednesday this week is here 2:30 to 4, and it's the journey and responsibility of historical personal property. Thank you for coming. She's not enrolled in this class, but the journey and responsibility of historical personal poetry, writing poems about Helen Keller's adult life, and it's going to be given by Gene Thompson. For those of you ever go by Sunny Slope, recently we're having a contest for Ollie logos, and evidently dozens of submissions were given to us, but it's been narrowed down to 4. And so if you haven't gotten an opportunity yet, go over to Sunny Slope and vote on them. And what you do is you go in and turn right into the parlor, and there's these posters that you can vote on which logo you like the best. And then you just write that number down and you put it in a glass jar on the mantelpiece. If you're really good, somebody will give you a piece of peppermint candy while you're there. Or 2 or 3 pieces, or 4 or 5. Ollie Game Night is Thursday, February the 28th from 3 to 5, and you can sign up for the Tuskegee Day Trip. If you haven't been to Tuskegee, it's a great historical town. And they're talking about the construction on College Street. Be careful around that construction. It's hard to see past the barrels, and it's awful confusing. And just in case it's not confusing enough on College Street, they're starting it on Shug Jordan this morning. So I'm going to turn off my cell phone. I don't want to embarrass myself while I'm teaching.
It would be really funny if you just leave it on.
I bet you would. Today's class is toxic items in your home. And I hope by the time that I'm through with this, you will get something enjoyable out of it and entertaining out of it. And I hope also you will get some information out of it that will help you to be aware about things. And if there are things that are in your home that I think you should worry about or you think you should worry about, I'm going to show you how to enlighten yourself to where you take a reasonable approach to it. First of all, I'd like to talk to you about environmental legislation. Now, we didn't have this kind of stuff before 1970. So let's go over a few of the rules about environmental legislation. Remember, we're from the government and we're here to help, right? So the first rule is NEPA, the National Environmental Policy Act. It was signed by President Nixon, I think, in 1970. And it says, if you must tell what you're going to do, you must tell how you're going to insult the environment before you insult it. The next item is OSHA, the Occupational Safety and Health Act. So that means that if you're going to do something that's an environmental insult, you must tell how you're going to do it. And the other one is the Clean Air Act, which means don't put anything up your chimney. Don't put anything up the stack at your industry. The Clean Water Act, don't put it out a pipe. So if you're going to insult the environment, don't put it out a pipe. And no, for all you environmental engineers, dilution is not the solution. This is the Safe Drinking Water Act. Do not put it in a hole in the ground. Resource Conservation and Recovery Act. Don't put it anywhere else. If you put it somewhere, they will make you come and get it and take it out. The Hazardous Material Transportation Act. Don't even carry it around. And the Toxic Substances Control Act, if it's such bad news, don't make it in the first place. And if you did make it, and you did put it in the ground, we're going to make you go dig it up. This is the CERCLAs where the Superfund sites came from. There are such bad actors, such bad places in the United States that they're going to find out who put it there, and they're going to make you go and dig it up. Now, some people think, oh, I know what I'll do. I'll put all this garbage in the ground, and then I'll go bankrupt. Nah, that doesn't quite work out that way. Whoever bought the land when you went bankrupt did not do their due diligence, and now they own your mess. So, this is all very confusing, so I'm going to let you read that yourself. They have a list of the nastiest items. These are items that are just absolutely unacceptable. They are a big insult wherever they occur. And in the United States, we have our eye on it. Our government does, even industry does, environmental engineers do. Most people have their eye on a certain list of pollutants. These are the absolute no-nos. There used to be 129 of them, but 3 of them somehow graduated from the list. Now, I don't know how they decided they were going to remove number 17 and numbers 49 and 50. I don't even know what they were before they removed them. But there's 126 items on this list. Absolute no-nos. For example, arsenic. They don't particularly care for arsenic. And chloroform, and there's some heavy metals in there. I once went to a site when I was as an environmental specialist for somebody who was doing their due diligence. The guy was buying a junkyard. Okay? And in the junkyard, of course, there are all these old cars. And in the old cars, there's all this used motor oil. Used motor oil contains the heavy materials chromium and cadmium in the motor oil. That's why your motor oil has to be processed specially after it's used, and it's collected where you get your oil changed. Well, this guy knew it. He says, I'm buying what's called a brown site. And that means that I know it's always going to be a junkyard, and that's what I intend to use it for, as a junkyard, so I'm buying a junkyard. But being the kind of guy I am, I always go to the lowest place on the land and look down there and see what's down there. Well, the lowest place on this guy's land was in a ravine in Tennessee. I don't hear laughter going on yet. But you know what you use the ravines in Tennessee for, don't you? Yeah, well, that's where your dishwashers and refrigerators and all kinds of other things end up with when you don't want them anymore. So I go down there, and there are 8 55-gallon drums. Each one of those 55-gallon drums has a hole in it about the size of a pickaxe. And I look on the side of the drum, and it says nickel plating. So I went back and I filed my report to the person who is going to buy it, the buyer. I filed my report and I said, I do not recommend that you take this piece of property because it has nickel plating drums that used to hold nickel plating solution, and the way the solution got out of those drums is through a hole called bleveting. You take a drum somewhere where you want to get rid of it and you knock a hole in it and let it run out. I get a phone call that night from the guy who's selling the property. And he says, my name is so-and-so. I'm going to say King. I don't know what his name was. My name is Mr. King, and I own the yard that you went to inspect. And I said, stop talking. He says, oh, no, it's okay. I got the drums taken care of. They carried them away. I said, stop talking. He says, don't worry about it. I'm getting them disposed of some. I stop talking. I have to write down everything you say to me. Now you're not only going to be responsible for the drums, but you're going to be responsible for where the drums went. For every substance on the face of the earth, you can ingest enough of it to kill you. How about water? How about salt? How about baby powder? How about aspirin? Aspirin. You can take enough, it will kill you. You can take enough aspirin that it will kill you. So we, in a very, very simplistic form, how many medically trained people do we have here, chemists or pharmacists? Okay. So this is a very simplistic form of what is called an S-curve. An S-curve is how biological entities respond to anything toxic that they're presented with. Actually, it's how they respond to anything that they are presented with. Now, there's different kinds of response. The first response, there can be no response. If you are thirsty and you drink a shot glass full of water, will you be unthirsty? No. You won't have much of a response, not a measurable response at all to drinking a shot glass full of water. But if you are very thirsty and you start drinking water, there's a certain point at which you drink so much water that you'll get sick. Did anybody ever hear of waterboarding? You ever hear of waterboarding? Is it possible that in waterboarding, 100% of the people that are subjected to that will get sick? Do you think? Is it possible that you could waterboard a person so much that they might die from it? Now, not everybody would die unless you administered enough water. You can drink so much water that it will fill up your esophagus and run into your lungs and you'll aspirate. And every one of us has an amount of water we could take in that it would kill us. So there is a dosage of water when ingested that 100% of people will die. It's called drowning. Let's look at an example using a different substance. This is an exposure to ionizing radiation. Now, if you want to know how much radiation can you endure. Before we get started here, I want to tell you that it's measured in rads up there. When we talk about biological items, it's measured in rems. A rem is also in becquerels. Now, I don't know anything about becquerels. That came along after my career got started. But it is rems and rads are a measurement of the amount of radiation you get energy-wise, ionizing radiation. A millirem is 1/1000th of a rem or 1/1000th of a rad. If you fly in an airplane and you're going from New York to San Francisco, just from cosmic radiation while you're riding in the airplane, you're going to pick up anywhere between 20 and 30 millirems. If you go and get a chest x-ray, you're going to get 75 millirems. That's 75% of 1 rem or 1 rad. I forget what it is for dentists, for dental x-rays, but it's not very much. So there's a certain point, I know you shouldn't do this, right down here, you see that little point down there where the curve begins? Okay, up to that point there is absolutely no response of biological entities to being exposed to radiation. That point is at 30 rads or 30 rems. So up until that point, they have never demonstrated that any biological specimen has any response to it. However, somewhere between 100 and 200 rads, that means that they will feel fatigued. They'll have a response to it. It's kind of just a temporary response to it. But an instant exposure of somewhere between 100 and 200 rads will produce, oh, I've got it written down here, will produce fatigue and weakness. Yes?
That diagram implies that 5 people out of 100 will die?
Not yet. Now, between 200 and 400 rads, people will begin to get fever, infections, bleeding, weakness, and hair loss. And the closer you get to the 400 rads, you're going to start having people die from it. So somewhere around 400 rads, you can get up to 50% of people exposed to that will die from it. At somewhere between 200 and 400 rads, you'll have fever, infections, bleeding, weakness, and hair loss. The people that die at up to 400 rads are usually compromised in some other way. The sickness is real and believable. At between 400 and 600 rads, people will have high fever, infections, bleeding, and hair loss. Everybody will get sick. Everybody will get sick, and up to 70% of people will die at an exposure of 600 rads. Remember Chernobyl? Soldiers, Russian soldiers were told to take these coal shovels, and one by one, they were sent out on the roof of Chernobyl and told to take that coal shovel and take as many concrete blocks, graphite blocks, that they could find on the roof and throw them back in the hole. That's all they had to do. And in a certain period of time, they'd call them back in. Well, those soldiers that were exposed to that radiation, about 70% of them died. At 600,000 rads, you're approaching, people will have high fever, diarrhea, vomiting, dizziness, low blood pressure, turn yellow, and your insides begin to dissolve. At 1,000 rads, everybody will die. The supervisor at Chernobyl, realizing that he'd made a mistake, decided to go into the control room, go into the reactor room and try to hand push the control rods back down into the reactor. That's right. He was toast. So this is an S-curve. Not all S-curves look like this. Some of them are very steep, like fentanyl. How much fentanyl do you have to take before you get to 100% of the people that take it will die? That happens way, way down. So the curve on fentanyl is almost vertical. So you can either feel good temporarily or feel good permanently. Now, we have to figure out some way to communicate toxic substances to the common man. So, okay, so this is like the Occupational Safety and Health Administration's fanfare for the common man on toxic substances. It's called the Emergency Response Guide. You can download it for free on your cell phone. You can get it for free off the internet. And if any of you wish to have your free copy of the Emergency Response Guide, just send me an email and I'll send you the link and you can download it and have it in your home. Now what this is for is when the police come up on an accident, they can look on the side of the vehicle and know what to do. Okay, so the police should have a copy of this Emergency Response Guide. How many law enforcement officers do we have? Anybody ever do that? You should be able to find one of these things in every police car. At least state troopers I know will have them. And the truck drivers who are driving the trucks, tractor trailers, should have one of these in that tractor trailer. Now, he doesn't know what he's going to go pick up, so he should have it there all the time. He doesn't know whether he's going to pick up truckloads of uranium or truckloads of sugar. Well, actually, they do know when they're going to get shipments of uranium. Now, suppose that you are driving down the highway with your brother, and your brother and you are going to go and visit your cousin in Jacksonville. Okay? Now, my brother drives, never mind. Anyhow, he drives very slow. Sue calls them milliquies. But anyhow, you're driving real slow with your brother and you're headed for Jacksonville and you're on 280. And all of a sudden a tractor trailer goes by at a high speed on the left-hand side, just goes flying by, and you notice there's a big cow looking over a windowsill, Elmer's glue. And you look on the back of that truck, and there's a sign that looks like this. That number is called a UN number. 2278 is the UN number for whatever that hazardous substance is they're carrying in that vehicle. Well, you get your cell phone out, and you start tapping around on your cell phone, and you bring up your handy-dandy emergency response guide, and you look up 2278, and lo and behold, it's N-heptane. Where have you seen that word before? It's written on the side of Elmer's rubber cement. So now you know that that thing, the hazardous substance that's in that truck, is N-heptane. So you come up on this accident, and all these people are standing around. The truck is on fire, but they've managed to drag the driver out of the tractor, and he's laying on the ground. And there's somebody trying to administer CPR to this guy. But all these people are standing around watching the truck burn. So you pull out your emergency response guide and say, what should these people be doing? So it says up there it's guide number 128. So you turn to guide number 128 in your emergency response guide, and this is what needs to be going on there at that accident scene. Tells you what the hazards are. It says keep unauthorized personnel away, stay upwind, uphill, or upstream. Move people away from there, put on protective gear. But some people are standing around there, all of a sudden they start to collapse. So what's that all about? Well, it turns out that stuff, this heptane, is heavy and stays close to the ground, and they're standing in the fumes. So you got to know what to do about that. Well, lo and behold, your emergency guide tells you what the first aid is when exposed to heptane in a flaming accident or in any accident. It tells you what to do. And this is for all of that 2278 UN number, all substances for all UN numbers, and the UN numbers are on the left. That Emergency Response Guide is free. And you can download it off the internet. If anybody wants it, send me an email. I'll send you the link. It's not a very expensive little book. It's just a little bitty handbook. About like one of those golden books, you know, you used to look up birds in. It's about that size. It's supposed to be in your glove compartment. The next thing is a material safety data sheet. Well, if you're going to make something and sell it to the public or have industry use it, you better be able to tell people what's in it, what to do about it, what the health hazards are, and everything. So virtually everything, including toner for your printer, has a material safety data sheet. Here's an example of one. Clorox bleach has an MSDS. So actually, you can download for free the MSDS for almost any substances. Any substance that could appear in your home, you can download the MSDS. You have a bottle of Lysol, you can download the MSDS for that. Actually, you can download the MSDS for baby powder. The MSDS will tell you a bunch of things, including the first aid measures, just like the Emergency Response Guide, but it'll give you the first aid measures for whatever this substance is. Guess what the first aid measures is for baby powder? Don't eat it. If there is any toxic substance at all, they will give you a thing called a CAS number. That's Chemical Abstract Services. Therefore, you can go online for free, look up that substance that they think is toxic in there. You can go online and find out what to do about it. Find out everything you need to know about that toxic substance. Chemical Abstract Service, CAS number. All this stuff is for free. It cannot be hidden from you, a member of the public. So if you want to know something about it, you go there and look it up. Now here's all the household items that you have that could be toxic. Okay, I know that everybody in this room is over 50. So I don't see how you can miss exposure to the vast majority of that list. So I decided to go through there and look at that, and I decided that I've never had lice before and never been treated for it. I've had no opportunity, nor did I even know you could control moss in your home. And so far, I haven't been exposed to any rat poison. If you don't like rats, adopt a snake and put him under your house. But anyhow, these are the hazardous products list for a household. Now, granted, if we're over 50, we've probably lived in a place where there's been lead paint. And a lot of these things are no longer incorporated in a home. For example, formaldehyde is no longer allowed in insulation in the home. You can't buy insulation now that has formaldehyde in it. Is that right, Jim? I don't think you can. Paint? Yes, paint. Isn't it on there, paint? I don't know. I know that if I want to get rid of the paint that was used to paint my house, I have some left over, I have to take it to a hazardous waste site. And it's latex paint. Yeah. What about your computer? Is your computer hazardous? Yes, it has these items in it that are hazardous. Let's look at one of them, cadmium. There's that CAS number again. Okay? That's the CAS number for cadmium. And if the Environmental Protection Agency comes to your house and starts digging around in your front yard and they find more than 7 parts per million cadmium in the soil, they can make you clean up your house your yard, reprocess your yard. They won't. And cadmium is in the emergency response guide. So if you encounter a truckload of cadmium, you will know what to do about it. It's very toxic by inhalation. Cadmium is accumulated in bioorganisms. It collects in there. As a matter of fact, most of the cadmium that you get, that must be the next slide. It can travel long distances, can be entrained as dust, as a light powder. There are cadmium compounds. You don't want to get it into the water because guess where it ends up? It ends up in oysters. How many of you like raw oysters? Come on. Come on. All right. I don't want it in my oysters. So I don't want any cadmium washing into the bay down there at Apalachicola, and I certainly don't want it in the Chesapeake Bay. But microorganisms, as soon as they encounter it, they begin to accumulate it. How many of you think that there is cadmium in fruits and vegetables? There is. There's trace amounts of it because there's trace amounts of cadmium in the soil. Now, critters that eat grass that grows in the soil that has cadmium in it are going to bioaccumulate cadmium, and it's going to be passed on to you in your porterhouse steak. So there's a certain amount of trace elements of cadmium that are unavoidable, and it's accumulated up the food chain. Workers in the non-ferrous metal industry. You're a very responsible person, and so you decide to responsibly dispose of your computer. So you take it to one of these collection things in Auburn or Opelika, and you turn in your computer. Well, if they decide they want to incinerate the computers, what happens to the cadmium? It's supposed to be collected in a bag filter. But no, they can recover the value of the computer. Some of those things in your computer are still useful. Just because your motherboard chokes on itself one morning and you decide to get rid of that computer, some of the chips and some of the parts of that motherboard are still useful. It's just not economically feasible in the United States to recover parts from your motherboard. So they send them to China. That's your non-ferrous metal industry. Those people will gratefully work on it for a few dollars a day and recover the parts in your computer. Now we have the Environmental Protection Agency has a level at which tolerance, they give a maximum risk level, a maximum concentration level, which any of these substances can occur in water, soil, and air. So sure enough, cadmium is listed on there, and when we bore down to it, cadmium, there's your 7 parts per million. In residential soil, 7 parts per million is the limit for cadmium. There's a limit for the amount of cadmium in water, and there's a limit for the amount of cadmium in air. Yes, sir? In your lawn, it's there naturally. It's there naturally. We're going to get to naturally occurring things here in a minute. And there's the 7 parts per million. And there's specific kinds of tests that the Environmental Protection Agency requires. There's quality control for the testing process for each one of these, and you have to prove, as a matter of fact, you send what's called a split sample, not a split sample. Split spoon, but a split sample. You have to send them a split sample. You send them randomly, you send them a jar of whatever it is that you're sampling, and they sample it on their own. and then they compare your results with their results. That's how you have to tell them, this is the method I'm using, and oh, by the way, here's a random sample of what I'm doing, and so they can see if you're doing it right. Here's that CAS number for cadmium, remember it? Remember I showed you there was a CAS number? So you can actually look up cadmium, or you can even download for free the CAS document for cadmium. So, is your computer considered hazardous waste? Well, guess what? The first 4 items are on the priority pollutant list. I like the little symbols they give them. That's scary, isn't it? What about that bottom one? Brominated flame retardants. Well, brominated flame retardants can make you crazy. They can make you bug-eyed. They can possibly give you cancer. They might cause developmental defects. They might screw up your hormone systems. They might cause you to get sick easier. And they can cause reproductive and long-term effects, including passing on some of that brominated flame retardants to your children. And it can keep you from being a girl. It's probably time for a break. Oh, no, trust me, you guys ain't had enough yet. Wait till you get back from the break. Let's give it, let's come back at 9:15. Why do they put additives in food? Now, you can buy food without additives, right? Kind of makes you wonder, excuse me, kind of makes you wonder what the Italians did before they added nitrates to the wine. But they put additives in there either to make it last longer or as a catalyst to enhance the flavor or something like that. But additives are put in food by the manufacturers for some, probably what's called chemical engineering reason. Now, we've already heard it about packaging engineers in here. So you have to say that there are people who are engineering food by putting additives in it. Is that a good thing or a bad thing? Well, it makes food last longer. See, when you go over to Europe, you will notice that the ladies go every day to the grocery store, or Dad has to stop at the grocery store on the way home, and they buy the food they're going to eat that night. So they're not so worried about additives, because they really don't. They eat so much fresh food over there, they don't really have it a lot. Also, the Europeans do not refrigerate their eggs. And they're worried about milk keeping for any period of time, so they irradiate milk. They just run the milk through radiation. It kills off all the bios inside the milk, and then they put it on the shelf. The milk does not contain any ionizing radiation, by the way, because it's only bombarded with particles. And the milk doesn't take on any ionization. But I can tell you what, a carton of milk that sits on the shelf in a German grocery store, you can drink it 2 years later. You can't drink milk in the United States 2 weeks later, can you? Or some people, you lose your sense of smell the older you get, you drink anything. Non-organic agriculture. This is free-roaming chickens and cows. This is agriculture where they raise things without pesticides and all the other things that they add in there. They don't add any antibiotics to the cow feed, and they try to avoid pesticides in what cows eat and so forth. But non-organic agriculture means they add things to it that are not occurring naturally. Salt. Is salt toxic? Yeah, you can eat enough salt that you can get sick. One time I had some popcorn while watching a football game. We're not allowed to have popcorn in our house during the Alabama games because my wife thinks if you eat popcorn, they might lose. We did not eat popcorn during the national championship. We did not eat popcorn. We did right afterwards, but not during. Anyhow, it's possible that you can eat enough salt and make yourself sick just at dinner. Put a little too much on there, and it will cause you to feel a bit nauseous. Sugar versus sugar substitutes. How many people put sugar substitute in your coffee? Yeah. Okay. Tea. You put sugar substitute in tea? Okay. I used to be addicted to Coke Zero. Yeah, Coke Zero. And I just, suddenly I thought, it just, anyway, it was a passing event in my life. Butter versus margarine. Margarine is completely artificial. You could put a stick of margarine out on a picnic table and you will not see a fly on it. We had a golden retriever, which when it was young was able to put its paws up on the counter. If the golden retriever could look up on the counter and see a stick of butter and you weren't looking, the butter was gone. Now, my wife does put margarine in certain things. I don't know why she chooses margarine over butter for those things. I don't ask such questions. But anyhow, if there was a stick of margarine sitting out there, the golden retriever puts paws up there and looks. It's not butter. It's not bacon either. So margarine is completely manufactured. Who wants to put a handful of lithium grease in your mouth? Some of us are just plain allergic to certain things. The only food that I know I'm allergic to biologically is hazelnuts. Not peanuts. I like peanuts and walnuts and pecans and cashews and love macadamias. And I love the smell of those German cafes when you go in there and you smell the hazelnut coffee. How many of you like amaretto? I tell you what, one sip of amaretto will send me into there, talk to the porcelain pony. So allergies, you have to be careful about, allergies can slip into your food. I have a grandson who's allergic to seafood, to crustaceans, shrimp, things like that. It doesn't have to be absolutely present in it. For example, you can't take a shrimp salad and then pick the shrimp out of it and give it to him. That's a no-go. So allergies are a very important thing. And so it doesn't take much shrimp for my grandson to get to the sick point on that S curve. Doesn't take much shrimp at all. Red dye? It is the same allergy? But there are trace elements and compounds in every single thing you eat. People don't like what's called GMOs. That's genetically modified organisms. They don't want you to mess with their natural corn and their natural wheat and their natural peanuts and their natural potatoes and their natural tomatoes and their natural olives. How many of you think that any of those items are not genetically modified? They all are. Wheat is modified, corn is modified, rice is modified, tomatoes modified, potatoes are modified. That's why tomatoes are large. That's why potatoes are large. That's why rice is large enough to see it. That's why corn is large enough to see it. Do you know what corn looked like when the conquistadors got to the New World? Do you know what corn looked like then? It was very tiny and very tough. And that's right, the ears were about that long. So there are trace elements of cadmium in your Cheerios. It's unavoidable, these trace elements. How do we live through all this? How did the human race ever get to where it is with all this trace stuff in our food? And we did it intentionally. My wife knows that I am addicted to beef jerky. So she says, look, what I want you to do is I want you to get on the internet and I want you to go and order some of this for yourself. So I did order it. I ordered paleo-friendly beef jerky. 100% grass-fed. All the people here who believe there's cadmium in grass, raise your hand. It's a trace element, but it's in there. This is the naked, original, paleo-friendly beef jerky. And I ordered this one here. This is a scan of the package. And I ordered 2 packages. I ordered the peppered beef jerky, too, because I love peppered beef jerky. I would have ordered the hot beef jerky, but they didn't have that because this is California. They don't do that sort of thing in California. So I went... I liked that beef jerky so much that I ran down to the Lake Martin Mall. How many of you have heard of the Lake Martin Mall? It's Dollar General. So I ran down to the Lake Martin Mall and I got myself another package of beef jerky. Only this one is not 100% grass-fed. It's just got beef in it, which is the main ingredient in the other one too. And it has pepper in it, and it's 96% fat-free. There's only so much fat you can cook out of beef jerky. So I try to say to myself, what is the difference? I cannot taste a difference between these 2 beef jerkies. Well, I'll tell you what the difference is. Do you think I'm worried about the cadmium and the 100% grass-fed? Do you know what does paleo-friendly mean? Let's go and eat like we did in the Stone Age. Pharmaceuticals. Now, this is not going to be a lecture on pharmaceuticals as we read about it in the newspaper. And this is not going to be a lecture on how much we take. Some people require a lot of pharmaceuticals to stay alive. I know that my brother is still alive now due to some of the things that he is taking after having 2 strokes. And he's doing well, by the way. And still drives kind of funny, but he's doing well. He lost the ability to play the guitar after his first stroke. This Christmas, he and I are going to do a classical guitar duet in church. These drugs, pharmaceuticals, are what saved his life, his lifestyle, and it maintained his quality of life. So this isn't about whether you take too much or too little. Pharmaceuticals are covered in the environmental industry by the acronym PPCPs. PPCPs. CPs. P. Notice it says cosmetics. Your cosmetics have an impact on the environment. Stop it. No, don't stop. Persistent is the key word here. There are elements in cosmetics and in all these, and drugs, pharmaceuticals, so forth, veterinary drugs, why does that concern you? Ends up in your meat products, poultry, beef, pork. If you got to worry about what's in what you eat, don't eat it. Some of this stuff is so persistent. How do you think it got in the water? How do pharmaceuticals get in the water? Do you think pharmaceuticals get filtered out at the sewage treatment plant? Anybody think it gets filtered out? No, it does not. It does end up in my oysters, and shrimp, crabs, fish. Those pharmaceuticals go into the water and they get consumed by the bottom end of the food chain. So what's in the air in your home? Oh, come on, I've only filled up about 30 minutes of the 2 hours that you have to lay awake between 2:30 and 4:30 and worry about things. So now, so let's talk about the air in your home. There's carbon monoxide. When you burn your eggs, you put carbon monoxide in the air. How many would pull a generator inside their home and start it up in order to keep your home functioning? There are people who do that. They will start a gasoline engine in their house. How many will cook in a hibachi because the stove doesn't work anymore? There are people that do that. Those people have died from doing that. You can buy a detector that will detect not only smoke, but it will also detect carbon monoxide. And you can hook it to your home alarm system, and you can actually have an alarm come on while you're sitting in your seat here that says there's carbon monoxide too much carbon monoxide in my home. Smoke, tobacco products, fireplace, candles, cooking residue. Those are sources of smoke. But you want to know what they're also a source of? One of the items on the priority pollutant list is arsenic. How many of you consume arsenic? Almost every day. Raise your hand. You all do. You do. Arsenic is a trace element that's also in your yard along with cadmium. Arsenic is in soil everywhere. And trees pick up arsenic and they bioaccumulate it in the bark. So when I'm burning firewood in my fireplace, I'm burning a bioaccumulated collection of arsenic in my fireplace. Do you think that there are people who are so desperate for heat and warmth in their home that they will go out to a construction site and pick up the construction lumber, take it home, cut it up into lengths, and put it in their fireplace? Do they do that?
Yes.
Have they died from doing that? Yes, they have. Do not burn construction materials in your fireplace. Wood preservatives contain all kinds of items that are on that list. Do not burn construction materials in your fireplace. Cooking residue. Some of the things that I cook shouldn't be eaten after I cook them. And natural gas in your house. It's my wife's idea to put the cow in there. She said I could blame that on her. When we owned our own surveying company, we went out to survey a site in Sunnyside, Tennessee. And part of the deal was the people that were asking us to survey it was a hunting lodge, and they wanted to know where their property was. And the reason they wanted to know where their property was is somebody discovered natural gas there. And so they wanted to be able to lease out sites for the natural gas. But one of the deals they made with the gas company was that they could siphon off some of the natural gas to their hunting lodge. What is the natural gas missing before it gets to the hunting lodge? It's missing mercaptan. Mercaptan is the smelliest substance on the face of the earth. And it's added to natural gas so that you know when it's leaking into your house. When I worked for Weston, right down the street here on Humphreys, I was sent to Pennsylvania to do surveys, baseline surveys of areas where they were planning to drill for natural gas. And the idea is during this fracking process, is this going to cause a release of natural gas into the drinking water, especially for these areas? We encountered one guy's home where we turned on the tap in his sink and sampled his drinking water. And his drinking water was 1,000 parts per million methane. Now, that's below the explosive limit for methane. By the way, he was sitting there chain smoking while we were doing it. He had no idea there was methane in his drinking water. I knew it from the instant I stuck the instruments in there, because I have to turn on an instrument that lets me know if I'm in the presence of methane while I'm testing. So I knew it immediately. But we're not allowed to tell people, oh, you have methane in your home. The Environmental Protection Agency and the contractor will tell them that, not worker bees that go around sampling water. Went to one well site that was way out in the middle of a farm field. It was one of those pumps that you lift the handle and the water comes on under pressure. It was freezing cold. It was so cold that I was using my knife to cut the tape around the lids of the sampling jars. And the water was freezing on my knife blade. And I am absolutely frozen solid wearing my ski clothes to sample for methane in Pennsylvania. And the farmer is standing there in his overalls and a short sleeve shirt. So I don't know why you're doing this now. Us boys used to show up early at school so we could take our Bic lighters and go around and light all the water coolers. The methane would accumulate in the water coolers at night, and they would light their Bic lighter and turn it on at the water cooler, and of course they'd get a big flame out of that. But the methane is naturally occurring in Pennsylvania. Much of it released by the coal mining industry. But anyhow, you can't smell this methane. That guy sat in his kitchen at 1,000 parts per million and had no idea. You want to tell those people at least open windows at night. If you want to accumulate methane in your house and you're in an environment that's full of methane, like all along the Appalachians, one way to accumulate is keep your windows closed. Chemical fumes. You know, every now and then you get a little mold in the shower or in the sink or somewhere like that, or in the bathtub. And you want to use one of those mold removers. Guaranteed 100%. You can buy it at Home Depot. You spray it on there while it's dry, and then you got to leave the room. The fumes are so bad. So just the fumes from various aerosols and things you use in your house, those fumes accumulate, and some of them are toxic, like that mold remover has hydrochloric acid, bleach in it. So the fumes from bleach that are irritating to you are from chlorine. Mold will cause problems in your house. You can get to the point where the mold, and some people are very sensitive to it, and it will show up. And by the time it really begins to affect you, it'll show up on X-ray and CT scans and radon. Now you could, come on, you got to have something to worry about. This is the periodic table. And here's radon on the periodic table. Do you know why it's purple? You know why I chose the color purple for radon? Because purple is the color of royalty. And radon is considered a noble gas. It's beneath radon to get involved. It doesn't enter into any chemical reaction. You will never find a compound that it has part radon in it. It simply doesn't get involved. It has all the electrons it needs. It doesn't have more electrons than it needs. It doesn't want to give them away. And it's not short any electrons, so it doesn't need to borrow any electrons from anybody else. It has just what it needs, and it's just not going to get involved. So therefore, it's inert. Radon does not combine with anything. Is there radon in your food? No. Is there radon in the soil in your yard? Yes. We're going to cover that. Radon is a byproduct of the decay of radioactive uranium. On its way to lead, lead is number 82 over here with 207, atomic weight of 207. And lead and uranium is 238. So uranium's got to shed some weight, got to lose weight. Uranium has to lose weight to become lead. How about that? Uranium has to lose weight, so it has to lose some protons and neutrons, and through a very circuitous process, it passes through radon. And then eventually it ends up losing enough weight to become lead. So it does this by fissioning or giving off particles. Radon is an alpha emitter. That's the symbol for alpha. An alpha particle is 2 protons and 2 neutrons. That's pretty heavy. That's the same as the nucleus of an entire helium atom. By the way, helium is a noble gas. It doesn't get involved either. Makes talk funny, but it doesn't get involved. So, 1 helium nucleus is the same as 1 alpha particle. So, here's the various types of particles that are naturally occurring fission. Notice that an alpha particle has a mass of 4.02, say, AMUs, atomic something units. And all the other particles are little tiny, and gamma rays don't have any weight. So, as a consequence, fat alpha cannot jump very high. He's just too big and ponderous. You don't see any big fat guys playing basketball, do you? They can't jump. Alpha particles are so large that they can't go anywhere. They can only go through a few centimeters of air. They can't go through the dead skin cells on your skin. So they cannot get through your skin to get to the living tissue underneath it. That's how big an alpha particle is. Beta particles can go all the way through paper but are stopped by aluminum. And gamma can go all the way through but is stopped by lead. A neutrino can go all the way through the earth. A neutron produced in reaction in a nuclear reactor cannot get through 18 inches of glass or 3 feet of concrete or 11 inches of lead. Fat alpha is 7,319 times the size of beta and gamma particles. The half-life of alpha particles is not measured in hours. The half-life of alpha particles, let me find my eyes. The half-life of an alpha particle, of radon, of radioactive radon, is 55.3 seconds. And the half-life of radon-222 is almost 4 days. Now, remember I told you that, let me see if it's in the next one. Yeah, radon is an inert gas which doesn't enter into any chemical reactions. So when you breathe in radon, does it go into your bloodstream? No. When you breathe in radon, does it stick to the cells in your lungs? No. In this book is listed for every radioactive substance what particular part of the body that it collects in or affects. I'm going to leave this book open, but when you get down to radon, it affects nothing. Nothing. So therefore, in order for you to be affected by radon, you would have to breathe in and hold your breath for somewhere between 1 minute and 4 days. And during that 1 minute and 4 days, one of those radon particles would have to fission and be right next to a piece of soft tissue in your lungs, would have to fission at that instant, and the alpha particle would have to penetrate through that whatever piece of soft tissue that it hits. It would have to hit a nucleus, and it would have to destroy that nucleus, but not enough that it wouldn't mutate and make cancer. Now, what I'm saying, is it clear? That the circumstances involved in a radon atom being inside your lungs, being close enough to some of the tissue, and fissioning at just that moment would have to be the first step in causing cancer. All kinds of people, like the World Health Organization, are telling us that there are 21,000 cases of lung cancer caused by radon every year. Not one of those cases has directly been attributed to radon. None. I have never read anywhere where they attributed a case of residential radon to a case of lung cancer. I am a geophysicist, and I will tell you that there are 3 kinds of lies. There's lies, damn lies, and statistics. Somebody took the number of cases of miners who work in an absolutely radon-rich environment and through a series of statistical manipulations, which I can go through to prove anything, they have statistically said that 21,000 cases must be caused by radon. The average accumulation of radon in outdoor air is 4 picocuries per liter. Is there anyone in here who wants me to explain what a picocurie is? No. That's the average concentration of radon in the air outdoors. Indoor air concentration, on the average, in American homes is 1.3 picocuries per liter. Yes, sir.
How would that get into your house?
Not yet. We worked this out ahead of time. Oh, I forgot to brief you on that. Okay. They want, who is they? They, the EPA, or they, the World Health Organization, or they, the people that sell radon mitigation products, suggest that you do something in your home if the concentration of radon gets between 2 and 4 picocuries per liter. That's what they want you. When you get a reading inside your home, and trust me, I can do that, certified environmental specialist, I can take care of that problem for you in measuring the radon in your home. No problem. I know exactly how to do it. Public action when it gets above 4 picocuries per liter. So if you're going to get radon at the mall, you have to get twice as much as you have to get at home before it's a problem. And if you work around radon, they don't want it to be more than 100 picocuries per liter. But if the EPA catches you at 30 picocuries per liter averaged over a year, they'll say you must be doing something wrong, and they'll say you're kind of in violation anyway, and they'll write you up. I've had people call me when I was maintaining my registration, and they say, "Can you measure the radon in my home?" Oh, yes, I can. Certainly I can. I will go and get the radon detectors, and I won't charge you too much extra for going and getting them for you. And I will place them in your house. I will go down to the deepest, darkest part of your cellar, in the bottom, in the crawl space, right down there where the soil is sunk down next to your foundation, right down next to the footer. And I'll put the radon detector right there. And I'll do it just before a low pressure area moves through. You know what happens when a low pressure area moves through this? The earth burps. That's right. It burps. When there's low pressure, there's gases. Radon is gas. The gases burp out of the earth when there's low pressure. So I'll be glad to put your radon detector in the lowest part of your basement when the earth burps. And then I'll bring it out and I'll read it to you, and your eyes will get real big. And you'll say, "Oh my God, 20 picocuries per liter." Next thing I say is, "Where do you live, ma'am? Do you mind if I put one on your coffee table? Perhaps I should put one in the bedroom, in the bathroom." You should only put these things if you're so inclined to do it. You should only put them where you live. Put one in your car. But you have a big problem if you're a Yankee. Because the action level for radon in the north and the northeast is higher than is required, that is recommended for you to take some action in your home. So that means that the air outside is higher than the action level in the northern part of the United States than it is for the action level in your home. Is that confusing? Actually, in the area where we live, it's low to moderate. Actually, if you want to live in the low area, you should, well, yeah, I guess Lee County's in the low area, isn't it? But still, it's less than 2 picocuries per liter. This is the radon potential in the United States. I don't know whether this is during high pressure or low pressure or averaged over a year. But it all has to do with the type of soil. Now, did I not tell you that radon was a gas? Okay. In your basement, how many of you have a furnace located in the basement? Raise your hand. How many of you have a washer and dryer located in the basement? Okay. How many of you have a basement? Oh, that answers a lot of questions. How many of you have a door or something that leads into your crawl space under your house? Okay. How many of you don't have a crawl space? Okay. Then you can't answer any questions, right? But how many of you in the crawl space in your house have those little square vent window things? Radon is a gas. And when the earth burps, any radon that may be underneath your house is going to go out through those vents. If you have a furnace or a washer and dryer in your basement, the dryer takes the gas from the basement and puts it out through a tube in the roof. Your basement is ventilated if you got a door that leads in and out of it. A gas isn't going to stay in the basement unless the basement is sealed. So why in the world would you take a radon detector and put it in the lowest spot of your basement and expect to learn anything about radon in the part of the house you live in? There was no EPA until 1970. There was no OSHA until 1971. It's all Nixon's fault. How did we possibly get old enough to enroll in OLLI if life is so hazardous in our home? I could say there's little likelihood that anyone in this room will get sick from any of these hazards. Don't worry about it, think about it. Remember that between 2:30 and 4:30, the things you think about in the morning happen. All three of those things are free. And this is all about recycling and being careful about what we throw away. So thank you for your attention. I hope this has been enlightening somewhat. And I'll be glad to take questions afterwards out in the hall while my wife is getting ready for the next class. And if you guys aren't through laughing, stay for that class. Actually, it's better than the one about medical things in World War I. Any questions? Okay, if you want the links to any of these free documents, just send me an email, and by return email, I'll send you the link on how to get it for free. You can put it on your the ERG, you can put that right on your iPhone. You just press a button. Every time you see one of those labels, 2278, you just press the button on your iPhone and search for 2278, and it'll tell you that heptane is in Elmer's glue. Okay, thank you.